Finished? Pick the value whichever is available on your paper.
Okay, doctor. Wait, please.
You can pick the values whichever is available on your paper. Done?
No, please, doctor. Wait. Doctor, that I have to write 17.2738 or what?
You can write complete. You can write any decimal accuracy you want. Only two decimal accuracy for graph.
Uh-huh.
Yes. 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 We'll talk about that next week. Next week, no experiment. Next week is review.
Okay, doctor.
We'll talk about the details of the lab exam next week. Yes, yes, for your section.
So, doctor, in the next lecture, doctor, you will talk about the final exam,
Yes, yes,
practical
yes. Next week is review week.
review week. Okay.
Okay, then I will play the video. We can watch the video now. Yeah, yeah. One more thing. You can
Doctor, can you
copy
please?
the source of error, major and minor source of error. Only major source,
Yes.
no minor source for this. And then we will go to the video. I don't know whether time is available for that or not. Now you can copy the major source of error.
There is no minor, doctor.
There is no minor for this section. Done? Okay. I'll play the video now. The video will give all the information. 10. Example 10 is simple. From the title, you can understand the mechanisms involved in this, physics involved in this very. We're going to talk about some oscillations in this experiment. First, let us go to the objective and then go to the actual. We have two objectives in this experiment. Objective number one, to demonstrate the independence of period of oscillation T, capital T, on the Bob's mass of a simple pendulum. Here we are going to demonstrate. The time period is independent of the mass. We're going to show it theoretically as well as experimentally. Objective number 2, to show the dependence of t, this time period, on pendulum length. L is the length of the pendulum. If t changes with the length, we are going to show this relation in our experiment and then use this relation to calculate the acceleration due to gravity. These are the two objectives of our experiment, and first let us take the first part. It is to show the independence of t on the bob mass. And this is our schematic diagram of a single pendulum, and this is called as a length. The bob is attached by a thread. It's an equilibrium position, and when you took it here, the tension is pulling the object in the upward direction. T is pulling in the upward direction, and this is the mean position, this is the current position. And when the object moves from here to here, it produces the angular displacement theta. Theta is the angular displacement. And the linear displacement is this. The mass of the object, the weight of the object is acting down. It makes an angle theta. Let us resolve this into two components. mg cosine theta is here, mg sine theta is here. Now the object is not moving in this direction, in the vertical direction, it is moving in the horizontal direction. Now F is equal to m. What is F here? F is equal to mg sine theta is equal to m. Right? Now, for small theta, theta is very, very small, smaller angular displacement. The sine theta is equal to theta. Now let me come to this. Mg theta is equal to m. M get cancelled. G theta is equal to a. Right? G theta is equal to a. Now, from this linear displacement, x is the linear displacement and theta is angular displacement, L is the radius of rotation. Now, x is equal to L into the relation between linear displacement, the radius of rotation, angular displacement. By substituting all these values here, and F is equal to, I can write, F is equal to minus mg theta, right? Equal to minus mg x over L is equal to instead of a, I'm writing all this. On simplifying this and writing the complex formula, the differentiating is equal to a equal to minus g over L x. A is the acceleration, g is the gravity, L is the length of the pendulum, x is the linear displacement. And this can be written as d square x by dt square. A equal to d square x by dt square. We differentiate the linear displacement with reference time 2 times, you will get acceleration. Plus g over L x. This is quadratic in x. And we can solve this by very long steps. And finally, you get t square is equal to 4 pi square g into m. This is the final step I'm getting. The time period t is equal to 2 pi square root of this square root of L over is the time period of the pendulum. T is the time period, 2 pi is a constant, square root of L over g. Right? And in this, the m is missing. Theoretically, I can show as m changes, the mass of the bob changes, the time period does not change. This is our first part of the objective. This is the first part I'm going to show. The t is independent on mass. The t is independent on the mass. I'm going to show that. This is the first part of the experiment. Let me come to this. This is the first part I'm going to do. The bob, the different masses I have, brass, aluminium, plastic, and wood. T1, time taken for 10 oscillation, trial number 1, trial number 2, trial number 3. Average, T1 plus T2 plus T3 divided by 3, you can get the average. This is the average time taken for 10 number of oscillations, right? Average 10 oscillations. How to find time period? This divided by 10. This is the time period. This is the time period for the brass pendulum. And you can repeat this experiment for different masses. And this is the experimental time period you have calculated.
Doctor,
Theoretical time period. The theoretical value.
Yes.
how we can get the T capital?
T capital, use the formula.
You said divide by 10. Or
Oh, that is from the schedule. T average by 10.
So, doctor, to calculate the T capital,
Yes,
the
follow
divide by
it, Shiva.
Equal to
Okay,
2 pi square root of L equal to 1 meter. You are fixing L equal to 1 divided by 9.8. If you simplify this much second is a theoretical time period. You can find theoretical by using calculator because L we are fixing L equal to 1 meter. By fixing L equal to 1 meter, you are doing all this. You can find the error percentage. The error percentage in the calculation of time period is T minus T theoretical. This is T. T theoretical, this one. T theoretical is this value. Substitute here. Divided by T theoretical into 100. You are getting the error percentage. Here I expect the error percentage less than 2%. I want the error percentage should be less than 2%. This is the first part of the experiment. And going to the second part of the experiment, the second part of the experiment I'm going to show the dependence of the time period on L. How can I show that? Let me go back to the same one. This T is equal to 2 pi square root L over G. Right? Now, I'm going to, as the L increases, what about the time period? Also increases. There is a direct relation between these two. I'm going to show that relations in my experiment, and by using the relations, I'm going to calculate G. Our main aim is to calculate G. Here, let us simplify this. Square root of L over G is equal to T over 2 pi. We're taking 2 pi to other side. I want to calculate G. Let me take the square. L over G is equal to T by 2 pi whole square. I want G. G is equal to 2 pi by T whole square into L. I'm going to simplify this. If I square this, 4 pi square L by T square. Yes, I'm simplifying this. 4 pi square L by T square. By using this formula, I'm going to calculate G in today's experiment. Let us go to the second schedule. The second schedule, L. Here, I'm changing the length. In the first part, I fixed the length. Now I'm changing the length. Length 100 centimeter, 80 centimeter, 60 or 40 and 20. And this is T1, time taken for first trial, time taken for second trial, time taken for third trial. Average of this. And divide this by 10. You can square. You're repeating the experiment for various values of L and finding. And finally, we're going to draw the graph between L square versus T square versus L. Let me explain you how you can perform the part 1 experiment. This is the part 1. Let me explain different part of the experimental setup. This is the simple pendulum setup. We have 4 different masses. The 4 different masses. This is brass, aluminum, plastic, and wood. These are the 4 different masses. Above I'm going to use. The length of the pendulum starts from this edge up to the center. Now, first, according to this schedule, I'll take the brass. Just hang the brass. Now it is hanging like this.
Yes,
The first part, I'm going to fix the length of the
the net
pendulum
was not working in the
as
morning.
1 meter.
Just okay.
As
I
1
was,
meter.
no, I came to.
Now, length of the pendulum starts from here.
Come. No problem. Come.
No problem.
There is a
No,
knob. By
finish it.
rotating this knob, you can fix the rope. You can move the rope or the first, just
Your doubt?
Huh? Sure, you are okay.
Yes. Not mushkil.
rotate.
I'll give the exam schedule Sunday.
Okay. Simple. From the title, you can understand the mechanism involved in this, physics involved in this very, very simple. We're going to talk about some oscillations in this experiment. First, let us go to the objective and then go to the actual. We have two objectives in this experiment. Objective number one, to demonstrate the independence of period of oscillation T, capital T, on the Bob's mass and release this. Now you can fix the length 100 centimeters. Now see this, there is a line drawn. This is 100 centimeter. The line touching 100 centimeter. Hold the rope. Now come to this and tie this. If we tie this rope, the length is fixed. The length will not be adjusted. Now this is done. I'm going to find the time taken for length is fixed 1 meter. Now find the time taken for 10 oscillations and go up to the 45 degrees from this. Bring approximately. Leave this, initially leave some oscillations. Now I'm going to start counting the oscillations, the time taken for oscillation. Now I'm going to start. We started 1, 2, 3, 4, 5, 6, 7, 8, 9, come down. And this is 20.02. 20.02 is the time taken for 20.02. It's time taken for 10 oscillation for cross. And repeat this experiment for second time, third time. 3 different times you are repeating. Sometimes you will get the same answer, sometimes different. Take the average. Add all these 3, divided by 3, you will get the experimental value of. After this, you are going to change the mass of aluminium. Now take this aluminium. I'm going to replace this by take out the cross. Now aluminium, the mass of
Only
the ball
6 students are here.
Now, again, you're going to find the oscillation, time taken for 10 oscillations. Then oscillate it and find the time taken for 10 oscillations. Record it here. Record here and take the average and record it. Next is plastic. Now the mass should be replaced by this is plastic box and replace this is plastic. The length is same but mass we are changing. Now give the oscillation. Find the time taken for 10 oscillations. Record it here. And repeat this experiment for the last mass is the wood. And place the wood here and you are oscillating it and find the time taken for 10 oscillations. And yeah. Then you have different values of the T values for the brasses. This is experimentally determined. The theoretical value we calculated from the formula, and using this formula you can find the percentage of error. I want the percentage of error less than 2% for this experiment. And come to the second part. The second part here, we are fixing the mass here. In the first part, we change the mass, fix the length. Now we are fixing the mass. You can take any mass. Out of 4, you can fix any one. Now, let it fix. The length is 1 meter. Already I fixed 1 meter. And I want to find the time taken for 10 oscillations. They give the oscillation. Now, the 1 meter is oscillation. Initially leave some oscillation because it may be not regular. Now I'm going to start counting. Now, 1, 2, 20.32. Now I can write it's 20.32. Repeat the experiment for 3 times. Take the t average and divide by this 10. T square this t. The next is 80 centimeters. Now take the ruler and attach to this.
You have the graph sheet, Ayman? Graph sheet enough? Graph sheet
Now
you have?
I'm going to fix 80
Graph
centimeters.
sheet,
How to
graph
fix 8 centimeters? Now let us see.
We need for next week for a lab exam.
Lose this one. Now can you lose? I can move the front.
Yeah,
up or
how
down.
many means
Now 80 centimeters. How can I fix?
250 for physics
See, there
1.
is a line
I don't know about how
drawn
many physics
at the
2.
center.
250
Now
means
this is going to touch 80 centimeters.
5
Where
books.
is 80?
5 books for physics 1.
For this one. Next week?
Yeah,
80
week after.
centimeter and hold this.
Week after. I think he may have. Ryan may have.
I think it's sometimes hard.
Now
It's not like in the past.
Yeah.
They will not give money. They will give the graph sheet
Now
itself.
come to this and give the
Saving our time.
stopwatch. And now the length is 80 centimeter and give the oscillations. Now it is oscillating. You can find the time taken for that oscillation according to the first try. Repeat the experiment for the second time, second try, third time. Get the average and record. The next is I'm going to change the length to 6 centimeter, 40 centimeter, 20 centimeter.
Doctor,
Every time you're changing the length,
Yes, Shiva.
find the time
we will
taken for
do the final exam on in the lab or in the regular class.
In the college.
Yes,
I
yes,
will give
I
you the
know.
complete details in the next week. Next
Okay.
week class I will give you.
Okay, okay. Doctor, sorry.
divided by this 10 t square. We are going to draw the graph between
Right for you on the
plot the graph between t square
5 for
versus
physics
L.
1.
T square should go to y-axis.
Full physics. Full physics 1, 5.
Full physics.
The L should
I'm talking about the total number.
Total.
Now let me come to this graph. T square.
That doesn't teach that.
L. I'm taking L
He
here.
is teaching.
L.
Yeah.
Yeah.
He's teaching.
Here.
Which one?
T square.
Pardon.
This one, two.
No,
Now you know how to
He's
change
teaching
the
now.
values. I will explain in detail in the class. And you will take the different values here and different values and plot all the point. After plotting the point, you can draw a straight line. Majority of the point should be touching the line. The majority of the point should be touching line. 1 or 2 points not touching the line is okay. Now, majority of the point touching the line. Next is the calculation of the slope. So I'm going to calculate the slope of the object, the slope of the graph. Then for calculating slope, I should consider 2 points. Both the points should be lying on the line. Now see, draw this line and draw this line. This is your x1. This is your y1. This point I cannot take because it's not on the line. I can select the other point. This is your x2 and this is your y2. Now I'm going to calculate the slope. The slope is equal to y2 minus y1 by x2 minus x. You can substitute x1, x2 value, y1, y2 value from the graph. Then I want to calculate the unit. For the unit of y-axis, secant square. Unit of the x-axis is centimeter. Now I want to convert the unit. Secant square by 10 to the power of minus 2 meter. Because the numerator it became 10 to the power 2 secant square per. Now I got the slope in terms of SI. What is the meaning of the slope? Come to this. The slope is equal to y quantity by x quantity. What is y quantity? T square. What is x quantity? L. T square by L is your slope. Now your G is equal to 2 pi L by T square. G 4 pi square is 4 pi square L by T square. This is the formula already we derived to calculate this. Slope. Slope is equal to T square by L. Here L by T square. So 4 pi square over calculate the slope. 4 pi square over slope gives you the acceleration due to gravity. G equal to something meter per second. This is acceleration due to gravity is determined for this. Come to the percentage of error. And data analysis percentage of error. The percentage of error G experimental. Whatever the value I'm getting experiment, write it here. Expected value 9.81, here 9.81 into 100. And this gives you the percentage of error. The percentage of error I expect less than 5% for this part. And the source of error. The source of error and conclusion I will explain you. The source of error I will explain you in the class. And conclusion, the period of oscillation T of the simple pendulum of the length 1 meter was found to be. Here we have to report the average value of T. Now here you can get the average of this T from the first part. Average of T, you report it. Right. The acceleration G due to gravity was found to be. This is the G value we calculated in the experiment. G should be reported. So details of the source of error I will explain you in the
class. Any other doubt?
Yes, doctor.
Only
Please,
6
how,
students are here.
doctor,
Yes.
how we calculate the T capital? T average the over 10?
T average over 10. Yes.
And the average for T, no, the conclusion, the doctor, he wants the T average, the T
The first
capital average.
schedule, you have capital T, right?
Yes.
There are 4 values.
For the
Take
first
the average of that.
schedule only.
Take the average of that.
Yes, for the first schedule.
Yes. First schedule, we have 4 T values. Take the average of that.
Please wait, doctor.
Oh, I forgot to record today. Okay, no problem.
Doctor, how we calculate the T theoretical?
By using the formula. See this formula. This formula, substitute L equal to 1.
L to 1.
Yes.
Doctor, can I use the formula T equals 2 by square root L over G
Yes.
to get the T theoretical?
T theoretical, substitute L equal to 1 meter.
1 meter.
Yes.
And to get the error, doctor, am I right?
To get the error for the first part,
Yeah.
this is the formula.
Yes.
This is the first schedule error. Second schedule error is different. Let's read the report. It is given just below the first schedule. The formula to
Yes,
calculate.
yes. Yes,
What
please,
is your
doctor.
question? You ask me the question. now the time is not enough. You ask your specific questions.
Doctor, the unit for the slope is what? 10 to the power 2
Unit of the slope second square centimeter. Then you can change it to second square per meter.
Uh-huh. Can I, Doctor, say... can I, Doctor, write 10 to the power 2
Yes, 10
second
to the
square
power of
per minute?
minus 2 in the denominator. It goes to 10 to the power of 2 as in the numerator.
Yes, second square per minute, per
Yes,
meter.
per meter.
Per meter. Yes.
Yes. What you want, you ask that question, Shiva. The time is not enough to do the complete activity. I already show the detail, the video.
Doctor, can you please do the delta x and delta y?
Delta x, delta y, you do it. You did it for 9 experiment, right? Why don't you try it for today, 10th experiment?
Doctor, we have enough time, please, Doctor.
Shiva, 10th experiment, why don't you try on your own? No, I'm not going to try. See, this is you supposed to do. I'm helping you to do so. Delta x, how to find? Maximum value minus minimum value divided by number of units. This is the formula.
Doctor, the
Every
t
time you shouldn't
square...
expect the spoon feeding, Shiva. I'm giving the method. You have to do one. Now you try your own. Now take the paper and find the maximum value in the x-axis. Find it.
Doctor, the x-axis will be L and the y-axis will be t square.
You have the report with you?
Yes.
What is written here? T square versus L. T square should go to y-axis. L should go to x-axis.
Uh-huh, okay. And to find the g, Doctor, 4 pi square over slope.
4 pi square over slope. Yes.
Uh-huh. Doctor, in the conclusion, the second part, he want the value of g and the percentage of error of
Error
what?
in G. Error in G. The second conclusion for the second part of the experiment. Second part of the experiment, you calculate G and then error in G.
Ah. So,
There are two
okay.
errors.
Yes, I have to calculate the error in the second part, the data.
Second part, yes.
Yes. And put the value of error in the conclusion.
Yes. Any other doubt?
Doctor, to get the T theoretical, I have to substitute 1 meter in the L.
Yes, L equal to 1 meter. Substitute value of G also. G is 9.8.
9.8.
Mm.
Okay. I got Doctor 2.0070.
2.0070. Okay, 2.007 take.
For T theoretical.
Yes. Yes. Mm. Less than 5 for the second part. First part less than 2.
Doctor, the unit for the T capital is second.
Second, yes.
Mhm. Doctor, in the
Yes,
conclusion, the first part, calculating the T average, for
yes, only
only
calculate
for
it.
the first schedule.
Yes, 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 yes.
Okay. So, doctor, I get the average and put it in the conclusion for the first
Yes.
schedule.
Mm.
Mhm. And the doctor, to calculate the T average, uh, the sum of the three values divided by 3.
Yes.
Doctor, and the first one, doctor, I got for the error 0.049.
Yes.
I can convert it to 0.05 or like it is.
Two decimal. Write it two decimal.
Oh, so I can write 0.05 only.
Yes. Yes.
Doctor,
Yes.
uh, in the plastic, doctor, I got the percentage of error is 0.
Okay.
No problem.
No problem.
Doctor, and the T average, doctor, I got 20.076. Can I convert it to 0.08?
Okay.
Mhm.
Yes. Yes. After 12. Yes. I have class. I will not be in my office. Today don't have office hour. After this, I have one more class.
Doctor, I'm sorry to get
Yes.
the average for the T capital for the first schedule.
Mm.
The sum of the four values divided by 4. Am I right?
Yes. Yes. That is the usual method of calculating average.
Okay. Doctor, for the brass and the wood, doctor, I got the same value for the T capital.
Yes.
It's no
That's
problem.
what we claim.
Mhm. So no problem for that.
That's what we claim. You see the first part, first objective.
Uh-huh. Doctor, to get the delta X, doctor, uh, can you please remind me?
Take the maximum value minus minimum value divided by number of units in the particular direction.
Uh-huh. For the X and Y also.
Yes, both.
What? And doctor, in the data, the analysis, we calculate the slope. After that, we calculate the G. After
Yes,
that, we calculate the source of no,
the error.
we calculate the error.
Error percentage. Yes.
Yes, and then in the conclusion, the first part, we put the average, the T capital average for the first schedule, and
Just
the
read
sixth.
and follow, Shabab. You are asking every step from me. The other doubt you can ask me. You are asking every step. How you will write the exam? The exam I explain every step.
Yes, yes, doctor.
You have to learn. If you have the really doubt, then you can ask me.
Okay.
The exam, who will help you?
Yes, of course, doctor.
You have to develop your skill. Yes, I know. But next, after 1 week, you are going to take the exam. Exam, you cannot ask a question like this.
Yes, yes, doctor. Of course, I know that.
Yeah.
So the okay, okay.
Even if you ask any question in the exam, I will not give you the answer. That is
Yes,
the
yes.
exam. You are coming to the college and take the exam for lab also. Shabab, I will go on to take some water, and my class starts another 10 minutes. One more class.
Okay, doctor.
Only
So
6 students are
you will
present
leave.
for this class. Now, for majority is missing, you can convey the message to your friends, submit the report by Saturday, right? For your section Saturday
Yes,
is
yes.
the deadline. Convey the message to your friends. Next week is a review lab class.
Review lab class.
Yes.
Inshallah.
We'll talk about the lab exam, how you are going to take the lab exam, and how much you score a mark, how to score the mark. All the details we will talk about it next class.
Yes, doctor. And how to study it. Okay, no
Yes,
problem.
yes, all the details.
Yes, please, doctor.
All the details.
Mhm.
Okay, I'll go and take some water from my office. I'll back to you.
Okay.
Okay.
Thank
See
you,
you in
thank
the
you.
next class.
Inshallah, doctor. Thank you.
Okay.